In this video, we are going to go over Charles' law and Gay-Lussac's law. So Charles's law is volume and temperature, and that it relates volume and temperature and shows that they are directly proportional for a fixed amount of gas at a constant pressure. As temperature increases, volume increases, and the temperature is always in Kelvin. The equation for Charles' law is the initial volume divided by the initial temperature is equal to the final volume over the final temperature. If you increase the temperature, the molecules move around a lot faster and the volume will increase. And that is why the volume increases, because you're moving around a lot more. So to practice, a 19.5 liter sample of neon gas is cooled from 76 to 38 degrees Celsius. What's the volume of neon at this lower temperature? So we're going to use our equation of initial volume divided by initial temperature is final volume over final temperature. I am going to write out my variables and figure out which one I need to solve for. Our initial volume is 19.5 liters. Our initial temperature is 76 degrees Fahrenheit, but I need to convert Celsius to Kelvin. So that is 349 Kelvin. So to convert Celsius to Kelvin, you add 273. So that's 349 Kelvin. I need to do that to the other temperature as well. So 38 degrees Celsius plus 273 is equal to 311 Kelvin. So my final temperature is 311 Kelvin, and I want to know the final volume. So I'm just going to plug in all my variables into my equation. So 19.5 liters over 349 Kelvin is equal to my final volume over 311 Kelvin. I'm going to cross multiply and divide, and my final volume comes out to be 17.4 liters. Gay-Lussac's law, it relates pressure and temperature. Pressure and temperature are directly proportional for a fixed amount of gas at a constant volume. And remember, for this, the temperature is also in Kelvin. So as pressure increases, the temperature increases as well. And the equation for this is initial pressure divided by the initial temperature is equal to the final pressure over the final temperature. So on the right-hand side, you see that you have two different canisters. One's at 200 Kelvin, the other one's at 400 Kelvin. And you have the same amount of molecules in there and it's the same volume. You need 2 kilograms of pressure on top of the first one to keep the weights at that part. You need 4 kilograms of pressure or the pressure of that pressure exerted from that weight to keep it at that same level. So you need more pressure at the higher temperature because there's more collisions going on, and so there's more energy going around in there, and so the natural tendency is to increase the volume. But if we want to keep it at a constant volume, we need to increase our pressure being applied. So to practice, before leaving, your tire pressure is 35.2 psi and the temperature of the air in your tires is 25 degrees Celsius. After driving, the tire pressure is 36.5 psi. What is the new temperature of the air in the tires? So our equation is pressure over temperature, initial pressure over temperature over the final pressure over final temperature. Our initial pressure is 35.2 psi. Our initial temperature is 25 plus 273. We need it in Kelvin. Our final pressure is 36.5 psi, and we want to know our final temperature. So I'm going to plug these numbers into my equation. So 35.2 psi, 298 Kelvin is equal to 36.5 psi over the final temperature. We cross multiply and divide, and our final temperature is 309 Kelvin, which is equal to 36 degrees Celsius. So to convert from Kelvin to Celsius, I just did 309 minus 273 to get 36. So Charles's law describes the direct relationship between volume and temperature when temperature is given in kelvins and moles and pressure are constant. So they have a directly proportional relationship. As volume increases, temperature increases. Charles' law expressed in terms of initial and final conditions is initial volume divided by initial temperature is equal to final volume over final temperature. Gay-Lussac's law describes the directly proportional relationship between pressure and temperature when the amount of moles and volume are constant and temperature is given in kelvins. As pressure increases, the temperature increases, and expressed in terms of initial and final conditions is the initial pressure divided by the initial temperature is equal to the final pressure divided by the final temperature.